All right, everybody, we are back with lesson 34. The first thing we're going to do is run back over our lesson 33 homework, which you should have already counted your problems and told me how many you have at the top of the page. These are your answers for A, B, C, D. And we discussed E in class. I think your book said do number C for E on the number line. You can always go back and stop the video and go back and look at these, but I'm just flashing them through one more time. This is F, and then 1, 2, 3, 4, 5, and 6. 7, 8, 9, 10, 11. 12 and 13. 14, 15, 16, and 17. 18, 19, 20, 21, 22, 23. 24, 25, 26, 27. And lastly, 28, 29, 30. So once you have graded right or wrong, you're going to count how many you have right and put it at the top of the page. Count how many you had in total done. Put that at the top of the page. Remember, if you did not do work or show work, then you only get a half for that problem being there. And then pass them to the front. Okay, so here we're doing lesson 34, proportions, ratio, word problems. And let's start with our little warm-up here. Number sense, $6.50 times 40. I'm going to get a little pen here. We went over these today in class, but I think of this as 6 1/2. And I multiply that by 40, and then I use a distribution where I say 6 times 40, which is 240, and 1/2 times 40, which is 20, and the answer is $260. Okay, so I can do that in my head because I changed it to mixed numbers. Okay, let's look at the next one. Fractional parts. 66 2/3 equals 2/3% equals 2/3. Find 66 2/3% of $45. Well, 2/3 is the same as twice 1/3. Okay, so if you have a hard time thinking about what 2/3 of 45 is, just think of, okay, what is 1/3? 1/3 of 45 is just 45 divided by 3, which is 15. So 2/3 would be 30. So 2/3 is twice the 1/3, and twice 1/3 would be 30. So $30 is the answer. Find the temperature indicated on this thermometer. Well, it looks like it's coming right across here. And this is 1, 2, 3 out of 5 little hack marks. And we know that 3/5 is the same thing as 0.6. So we would have 56, because this is going from 50 to 60. So 0.6 of the way through there is 6, because there's 10. So 0.6 of 10 would be 6. So we would add the 6 to the 50 and get 56. Another way to do that is just to think, okay, if you're taking 10 steps and you're dividing it into 5 hack marks, then each little hack mark is 2 steps, and we're going up 3, so 3 times 2 is 6. And you don't even have to worry about the 0.6 of 10, which was just how I thought about it the first time. All right, proportions. Caesar finished 12 problems in 20 minutes. At that rate, how many problems can he do in 60 minutes? Okay, so 12 problems in 20 minutes is his rate. Okay, and then we're looking at how many problems in 60 minutes. So we'll put a little question mark up here. So don't we know that 20 minutes times 3 is 60 minutes? So wouldn't we multiply the top part also by 3? And 12 times 3 would be 36 problems. If he kept at the same rate, he would get 36 problems done in the 60 minutes. Percent, 20% of 90. Now, you can do this easily two ways. You can think of what is 10% of 90, and 10% of 90 would be 9. Okay, so basically 10% is dividing by 10, and 9 times 2, because 20% would be twice that, is 18. That's one way to do it. Or you could say 20% is the same as 1/5, and 1/5 of 90 is 90 divided by 5, which is 18. Okay. Find the area of this rectangle. So area is length times width. On a rectangle, length times width. So we need to multiply 10 point, oops, I lost my 0. 10.1 times 3. And that's easy enough that we can do that in our head, right? That's 30.3. But now it's area, so it's square meters. G, list all the perfect squares from 16 to 64. Now, we did this before, and I did it between, and it's not supposed to be between. It's starting with 16. So 16 is 4 squared. So 5 squared would be 25. 6 squared would be 36. 7 squared would be 49. 8 squared would be 64. So we're getting all the way from 16 to 64. And then it says approximate the square root of 26. Well, the square root of 26 would be very close to the square root of 25, which would be 5. And 4.9 would be very close to 5. So we're going to take 5 times 5 is 25. Okay, now we probably got that pretty close because notice this one we estimated lower, but this one we estimated higher. So they're probably going to come out pretty close if we actually did the work. Oh, one of the fun ones here. So 10 take away 9 is 1 times 8 is 8 plus 7 is 15 divided by 5 is 3 times 6 is 18 plus 4 is 22 minus 3 is 19 plus 2 is 21 divided by 1 is still 21 divided by 3 is 7 times 2 is 14 minus 4 is 10 times 5 is 50 plus 6 is 56 divided by 7 is 8. Whoo! I'm tired now. And proportions. A proportion is a statement that two ratios are equal. The ratios 2/4 and 6/12 are equal and form a proportion. Now we're starting our lesson, so hopefully you're starting to take your notes here. Okay, 2/4 equals 6/12. They both equal a half, so they're equal to each other. Equal ratios will reduce. All right, we don't really use the word reduce as much anymore. We use the word simplify because those fractions are not getting any smaller, are they? They're not getting any smaller in value. They're just changing the way they look and we are simplifying the terms, but we are not changing the ratio at all. Both 2/4 and 6/12 simplify to 1/2. Notice these multiplication relationships between the numbers in the proportion. Okay, so 2 times 3 is 6. So basically, this is 8 times 3, and this is 8 times 3. So we know that they're equal to each other because we multiplied by 3/3, which is 1 to get from 2/4 to 6/12. Anytime we multiply by 1, we wind up with the same valued number, don't we? Okay, one ratio in a proportion can be expressed as the other ratio by multiplying the terms by a constant factor. 2/4 times 3/3 is 6/12. We can use this method to test whether ratios form a proportion. For example, to park for 2 hours, a lot charges $3. To park for 3 hours, the lot charges $4. Okay, so for 2 hours gives you $3, and 3 hours gives you $4. Is the time parked and the fee charged by the lot a proportional relationship? Why or why not? Now, if it was proportional, then we would be able to multiply 2/3 by some constant 1 to get 3/4. Okay? And we can't do that. And we know that because 2/3 is 0.6 repeating, and 3/4 is 0.75. We are not charging the same ratio at all, are we? It is not proportional. Okay, Nora is paid $12 an hour. Is her pay proportional to the number of hours she works? Yes. Why? If she works 1 hour, she gets paid $12. If she works 2 hours, she gets paid $24. If she works 3 hours, she gets paid $36. Okay, so the number of hours that she works times 12 will give you the amount of money that she makes. Therefore, yes, her pay is proportional to the number of hours that she works. Okay, so here's the solution. We can make a table for her pay for various hours of work. We see that the ratio of pay to hours worked is constant. The ratio does not change. Any two ratios form a proportion. So here we have 1 hour, 2 hour, 3 hour, 4 hour, just like I did. And then we're multiplying by 12, so she gets $12. 2 times 12 is 24. 3 times 12 is 36. 4 times 12 is 48, and then we did the ratios. 24 per 2 hours of work is the same as 12 for 1 hour work. 36 for 3 hours work is the same for 12 for 1 hour work, and so forth. Therefore, Nora's pay is proportional to the number of hours she worked. Nelson has a paper route. If he works by himself, the job takes 60 minutes. If he splits the route with a friend, it takes 30 minutes. If 2 friends help, the job takes 20 minutes. Is the amount of time it takes to complete the route proportional to the number of people working? Okay, well, let's see. If he does it by himself, he has 60 minutes and 1 person. Okay, if he does it by 30 minutes, let's see, 30 minutes is for 2 people. If he does it in 20 minutes, that's for 3 people. Do those rates wind up being the same? No, they're not the same rates, are they? So 30 minutes for 2 people, 20 minutes for 3 people. Okay, so basically here they're showing you that it is not a proportional relationship. Now, it completely makes sense because if you took the 60 minutes it takes him to do it divided by the 2 people doing it, it would be 30 minutes, right? And if you took the 60 minutes it usually takes him to do it alone and you divide it by 3 people, then it would make sense that each person would do it in 20 minutes. Okay, but he's dividing the work. It's only proportional if the original rate equals all of the other rates. Okay, so they're showing you, the table shows the number of workers and the number of minutes needed to complete the job. The ratio of time to workers changes. So 60 minutes for 1 worker, okay, and then it says, so basically for 2 workers, it's 30 minutes, but look, when you simplify 30 over 2, you get 15 over 1. So the rates for 1 person are not staying the same. They're dividing the work up, aren't they? There is a relationship between the number of workers and the time to complete the job, but the relationship is not proportional. So we're trying to learn what proportional means. We can use proportions to solve problems where one of the numbers in the proportion is missing. A variable represents the missing number in the proportion. So 2 is to 8 as 6 is to x. One way to find the missing number in the proportion is to use the multiple between the terms of the ratios. So 2 times what is 6? Well, we know that is 3. So it would have to be 8 times 3 is something, and that something, x, would have to be 24. So to complete the ratio, we would say 2 is to 8 as 6 is to 24. And when we write it all out like that, we can see times 3 times 3. By multiplying 2 eighths by 3 over 3, we find the missing term is 24. Below, we show another relationship we can use to find a missing number. Okay, so when we're doing this one, again, we can find that the missing number is 24. Now, what they're doing here is 2 times 4 is 8. So they're saying 2 times 4 is 8. Therefore, 6 times 4 would have to be 24. Okay, so here, let's use one of those that they gave us. So here, if we're starting, our missing number's over here. So if we want to, we can start over here. 8 times what is 24? Well, 8 times 3 is 24. And 5 times 3 would give us 15. Okay. So they're showing you going backwards just like we just did. 5 times 3 is 15. All right, so here we have ratio word problems. Can include several numbers, so we will practice using a table with 2 columns to sort the numbers. In one column, we write the ratio numbers. In the other column, we write the actual counts. We can use a ratio table to help us solve a wide variety of problems. So, in example 1, it says the ratio of boys to girls in the class is 3 to 4. So we could say boys to girls is 3 to 4. Okay, now if there are 12 girls, so now we can take our girls away. If there are 12 girls, how many boys are there? Okay, so our complete information is down here on the bottom, isn't it? So we would say 4 times what gives us 12, and that's 3. Therefore, we know we need to multiply 3 by 3 to get 9. So there would be 9 boys would make the proportion true, wouldn't it? Okay, so here they're showing us 3/4 equals B over 12, the actual count, and we wind up figuring out that 4 times 12 is 3, therefore 3 times 3 is 9. All right, so now we're doing our little practice set here. Which pair of ratios forms a proportion? Okay, so what are we going to do? We're going to say, all right, 3 times what is 6? Well, that's 3 times 2. Is 6 times 2 9? No. That one is not a proportion. Okay, here we have 6 times 2. 3 times 2 is 6. 6 times 2 is 12, so that one is a proportion. And here we have 3 times 2 is 6. 6 times 2 is 12, and we should get a 12 right there for it to be a proportion. How do you know your choice is correct? Okay, because we multiplied by 2 over 2 and got 2 over 2 is 1. So we multiply by the same number on the top and the bottom. Now, they're going to show you a little bit later, but we can also try a proportion. 3 over 6 equals 6 over 12. And we know that's true because we multiplied by 2. That's an equal sign, not a minus. We got times 2 times 2. So we know that this is correct. But look at another relationship that is here. Look at 3 times 12 is 36. And 6 times 6 is 36. We call that cross multiplying. And it only works over proportions. Okay, so that's another way to check it. All right, so let's get a different color. Okay, so we'll match our screen here. Solve each proportion. So 6 times what gives us 18, and that's 3. So 4 times 3 is 12. C must be 12. Okay? And now, let's do this one a little bit differently. Remember, we could say times 2 times 2, so that would be 6. Or we could say 9 divided by 3 gives us 3. 18 divided by 3 is 6. We could do it both ways. All right, so notice that this is more difficult multiplication. But what if we realize that this is a times 3? So this is a times 3. In other words, instead of worrying about 9 and 15, why don't we do it vertically? Okay, so I know 15 divided by 3 is 5, so 9 divided by 3 is 3. That's the easy way to do it, right? Okay, so here we've got the unknown on the bottom. And again, we have a more difficult relationship here. So why don't we go this way? 3 times 4 is 12. So 4 times 4 is 16. We don't have to deal with just the 4 and the 3. That would be more difficult. Okay, a wholesaler offers discounts for large purchases. The table shows the price of an item for various quantities. Is the price proportional to the quantity? How do you know? Okay, so for a quantity of 10, we're going to pay $30. Okay, for a quantity of 100, we're going to pay $200. For a quantity of 1,000, we're going to pay 1,000. So this is definitely not proportional, because here we have 30 divided by 10. That's $3 for each item. 200 divided by 100 is $2 for each item. And 1,000 divided by 1,000 is $1 for each item. Okay, now to show it is not, we could just write any one of these and show that they are not true. So 30 over 10, 200 over 100. Okay, so isn't this a times 10? And this is definitely not a times 10. So this one is definitely not proportional. A retailer sells an item for $5. Brenda needs several of the items. Is the total price proportional to the quantity purchased? How do you know? Okay, now here they're not talking about, these are not related, right? This is G, this is H. They're not related to each other. Each item sells for $5. So Brenda needs several of the items. So isn't the number that she needs times the 5 going to be how much she has to pay? They're not talking about any kind of reduction for buying in bulk or quantity, are they? The total price proportional to the quantity of the purchase. Yes, because if she buys 4 of them, she's going to pay $20. Okay, think grocery store. If you go in, for the most part, unless there's a sale going on, if you have ice cream, a bucket of ice cream for $5 and you want 4 buckets of ice cream, aren't you going to pay $20? Because he's going to charge you $5 for each bucket of ice cream. That is proportional. Okay, solve problems I and J by creating a ratio table and writing a proportion. The ratio of the length to width of a rectangular room is 5:4. Okay, so let's draw a little picture here. Not a very good picture. Okay, so we're going to say, and it's not a very good representation because that definitely does not look 5:4. Let me say try again. 5:4. Okay, so that at least is a little bit better. Okay, so this is 5 and this is 4. Okay, now that doesn't mean that is, we could say length to width is 5:4. Just because they said the ratio, so what we're going to do instead of just 5, we're going to put 5 times some constant and 4 times the same constant. Okay, so we're going to put a little x in there, but the x is the same on both. Okay, so the ratio of the length to the width of the rectangular room is 5:4. If the room is 20 feet long, so now we have a relationship. 5x is 20 feet. Therefore, x is 4. So we put a 4 right there in place of the x. 4 times 4 is 16. Okay, now we just did it on the chart. Let's go ahead and do it with the relationship. So we're going to say 5:4 is, remember the length is now 20 to something. Okay, now this x right here is not the same. I'm going to go ahead and erase those so they don't confuse you. Okay, so we're going to solve this proportion. 5 times 4 is 20. 4 times 4 is 16. So the width of the room is 16 feet because it's in feet just like the length was in feet. The teacher-student ratio in the primary grades is 1:20. If there are 100 students in the primary grades, how many teachers are there? So if you have one teacher, okay, for every 20 students, and then that's your ratio, you're ruling, that's your rule here, and then in reality there are 100 students, then 20 times 5, and we would have to have 5 teachers because we have to multiply both. Okay, so now written practice number 1. Mark's cell phone company charges 33 1/3 cents for every minute they go over their plan. If Mark goes 27 minutes over his plan, how much money will his cell phone company charge him? Okay, so we don't know. So basically, they're paying for their basic plan. So this would be charge him for the extra minutes. Okay, so if we said 33 1/3 cents, isn't 33 1/3 exactly 1/3? So we would say 1/3 of $1. Okay, 1/3 of $1 for per minute. All right, so we can always make it a little bit easier to us. 1/3 of $1 per minute. So he's going to go 27 minutes times 1/3 of $1. And he's going to wind up 27 divided by 3 is $9 is what he's going to get charged, because this is dollars. 1/3 of $1, 27 times 1/3 of $1 is $9. He will be charged $9 above his plan rate. Juan ran the 100-meter dash in 11.91 seconds. Steve finished behind Juan with a time of 12.43 seconds. How many seconds slower than Juan was Steve? Okay, so Juan ran in 11.91. Steve finished behind Juan with a time of 12.43. It took him longer. That's why his time is greater. It took him longer on the clock. So how many seconds slower? So this is just subtraction, isn't it? 12.43 minus 11.91. And 3 minus 1 is 2. 14 minus 9. Oops, that doesn't look like a 14. 14 minus 9 is 5. And 52 hundredths of a second. Okay, so how many seconds? 0.52 of a second, which is very close to a half a second. Okay, so 0.52 of a second. The ratio of the base of a certain triangle to its height is 3:2. If the base of the triangle is 24 inches, what is the height of the triangle? Okay, so let's just make our little ratio. The base to the height is 3:2. Okay, that's the ratio. If the base is 24 inches, so we're going to say base to height, base to height. Okay, so now we could go this way. It's easy. 3 times 8 is 24. 2 times 8 is 16. Okay, so 24 over 16 does simplify to 3/2. So 16 inches would be the height. Ooh, that's a really weird inch. And number 4, a sculpture in the center of the bank lobby cast a triangular shadow on the west floor when the sun shines through the east window in the morning. In the afternoon, the sun shines through the west window, casting the sculpture's shadow on the east floor. The change in the position of the shadow from morning to afternoon corresponds to what kind of a geometric transformation? Okay, so basically what they're saying here is, here's this sculpture. There we go. There's the sculpture. Okay, and it cast a triangular shadow on the west floor. So I'm going to make this west. And we're going to make this triangular shadow on the west floor. When the sunlight shines through the east window onto, there's the east window, okay, in the morning. In the afternoon, the sun shines through the west window, casting the sculpture's shadow on the east floor. The change in position is due to a reflection, isn't it? That is a reflection. Hopefully you got that right. And number 5, simplify. Now, remember we only want to add them together. So we're going to change this to addition of the opposite and addition. Scratch that out and make it the opposite. Okay, so now we have everything in terms of addition, addition, addition. So let's just go left to right. Same sign, add, take the common sign. So add the 3 and the 4 is 7, take the common sign, which is minus. And now we're going to take this one, this result, and add it to the plus 5 by addition. Opposite signs, aren't they? Opposite signs subtract. 7 minus 5 is 2. Take the sign of the greater absolute value, which is negative. And lastly, we're going to go with negative 6 and negative 2, which is same sign, add. Take the common sign, which is negative. So negative 8 should be our answer. Another cool way to do this that's easy is to take all of one sign. So here's a negative, here's a negative, here's a negative. So you know they're going to go in the same direction. So that would be negative 7, and then another negative 6 is negative 13, and negative 13, and then adding a positive 5, opposite sign, subtract 8, take the sign of the big guy. See, you get negative 8 either way, whether you do them in order from left to right or whether you group them by sign. As long as you've got a plus sign in between them, they should give you the same answer. Number 6. Okay, so on number 6, it says true or false, some rectangles are rhombuses. Explain. Okay, so we have to think about what are rectangles and what are rhombuses. So let's start with rhombuses because they're less familiar. Rhombuses only have one requirement, 4 congruent sides. Okay, so a 4 congruent sides could be a square, or it could be what I call a smushed over square. Okay, both are rhombuses. So a square is a rhombus, and a rectangle is a side that has 90-degree angles, a figure that has 90-degree angles, and opposite sides are parallel. Okay, so if you're thinking about it, doesn't a square have 90-degree angles and aren't opposite sides parallel? Okay, so we could say a square is a rectangle and a rhombus. So since a square is a rectangle and a rhombus, then yes, some rectangles are rhombuses. A square would fit into both. And the last one, it says simplify 7 to the 7th times 7 to the 0. Now remember, 7 to the 0 is 1. So 7 to the 7th times 1 is just 7 to the 7th. And remember, we just add these together when we are doing our multiplying like bases. We add the exponents together. And then down here on the bottom, we have 7 to the 5th times 7 to the 12th. We add the 5 and 2 together to get 7 to the 7th. 7 to the 7th over 7 to the 7th is 1 because the numerator and denominator are exactly the same. We are out of material for lesson 34. We are done. Make sure that you do your homework packet, and we will see you on Monday. This is Mrs. A, and may God bless your day.